Okay, so we're looking at example 3, the try it. So we know the try it's in the books are just like additional examples. And this example says a factory purchased a 3D printer in 2010. The value of the printer is modeled by the function f of x equals 30 times 0.93 raised to the power x, where x is the number of years since 2010. So obviously this is the function, the exponential function that we're going to be using here. So then in part A it says, what is the value of the printer after 10 years? So understanding that function, we can sort of break it down into the different parts, right? That 30 would be the A value. The 0.93 would be the B value. And of course, x is the exponent here, and in this case, it's standing for the number of years since 2010, right? They tell us that straight out. So to answer part A, we're just going to plug in 10 for x and find out what the answer is. So I'm going to do f of 10 equals 30 times 0.93 raised to the 10th power. And then we can throw that into the calculator. So we get 14.52, which the value is in dollars most likely. I don't know that they really specified a unit. So $14.52. All right, so go on to part B. Does the printer lose more of its value in the first 10 years or in the second 10 years after it was purchased? Okay, so first we have to find how much value was lost in the first 10 years. And that requires understanding the function a little bit better, because it's not like they told us in the problem that the initial value of this 3D printer was $30. But if we look at the function again, that value right there, that A determines the y-intercept on our graph. Remember, this is something that we've talked about. It's the vertical dilation. Now, the y-intercept on the graph has an x value of 0. Well, in this problem, x stands for time. 0 time would be 0 years after 2010, which means at the beginning of this 3D printer's life, right? So that 3D printer initially had a value of $30. Now, based on that understanding, we can find the value that was lost over the first 10 years, because we can take that initial value and subtract the value of the 3D printer after 10 years. Throw that in the old calculator. Okay. $15.48 was the value lost. I'm going to label this lost in the first 10 years. All right, now we have to find the value lost in the second 10 years. So to do that, we're going to take the 1452 minus whatever the value of the 3D printer was after 20 years. So the first thing we're going to have to do is calculate f of 20. 30 times 0.93 raised to the 20. So this comes out to be $7.03. So now we can take the $14.52, which was the value after the first 10 years, subtract the $7.03. So we get $7.49. So the first 10 years, it lost $15.48. The second 10 years, it lost $7.49. So the question was, does the printer lose more of its value in the first 10 years or the second 10 years after it was purchased? Well, obviously, it's losing more in the first 10 years, right? So there we go. So we'll take a look at one more here, example 4 out of the book. And this one says, a car was purchased for $24,000. The function y equals 24 times 0.8 raised to the power x can be used to model the value of the car in thousands of dollars x years after it was purchased. Okay? So based on our understanding of exponential functions now, there's our a value, which we now know is the original value of the car, right? 24,000, 24 for the a value, they correspond. There's our b value, 0.8. So let's go to part A. Does the function represent exponential growth or decay? Well, we just talked about it, right? The 0.8 is the deciding factor there. Since it's less than 1, it is exponential decay. Part B. What is the rate of decay for this function? What does it mean? So the decay factor is going to equal 0.8. It's that b value right there in the exponential function, right? The decay factor is 0.8. Now, since that is less than 1, we know that the value of the car is decreasing. It's decaying. Now, the next question is, by how much is it decreasing each year, right? And this is where we take 1 minus that decay factor, so 1 minus 0.8, and we get 0.2. And 0.2 as a percentage is 20%. So when they ask us here, what does it mean? Well, what this all means is that the car is losing 20% of its value each year. Right? I don't know if you guys have been told this before, but when you buy a new car, as soon as you drive it off the lot, right, that's where it loses most of its value. And a car is a depreciating investment, right? Unlike a house, where usually the value of your house grows, the value of your car never grows. It only goes down, right? And we see that in this example. The value of this car is decreasing by 20% each year.